All right, so we're going to continue our systems talk in this chapter by looking at applications, which are word problems, okay? The good thing about today is it says write a system of equations to solve each problem. So we're going to be writing the equations, not necessarily solving. On your homework, you may have to solve a couple, but we've been working on that for a while. So anyway, what it wants us to do in these is read the examples. It wants us to define the variables. I like using X and Y, but a lot of these, like number 1 talks about pens and markers. Feel free to use P and M. Doesn't matter to me. It says 8 pens and 7 markers cost $3.37, while 5 pens and 11 markers cost $3.10. Write the system of equations to find the cost of each pen and marker and state how you would solve the system. So again, I like X's and Y's. If you want to use like P for pen, M for markers, that's fine. I'm going to say that X is the cost of pens. And I'm going to say that Y is the cost of markers. Okay, and then once I've defined my variables, and really how you find that would be, it does say find an equation, a system equation to find the cost of each. That would be where the X and Y would come in. So I know in one situation I bought 8 pens. I don't know how much pens cost. That's X. In another situation, or in the same situation, I bought 7 markers times its cost, which I don't know, but I do know it costs $3.37. And if you get that one, the other one's pretty easy as well. I've got 5 pens times their cost plus 11 markers times their cost equals $3.10. Now, the last thing it asks us is how you would solve this. And I think most of the time when they're, especially if it's in standard form, elimination is the way to go. Elimination. Let me just start that over. Elimination. Sorry. Making this on a Monday morning. Now, you could use other ways to solve it. You could use substitution if you wanted to, but I think elimination is the easiest. Number 2, a movie theater sells tickets for $8 each, with seniors receiving a discount of $2. One evening, the theater sold 525 tickets and took in $3,580 in revenue. How many of each type of ticket were sold? Well, the variables are going to be each types of ticket. Well, there are 2 kinds. I'm going to say X is a regular ticket, and I'm going to say Y is for seniors. So I know that X plus Y will give me the total number of people that went, because X is the number of regulars, Y is the number of seniors. So my first equation is X plus Y equals the total number of tickets, 525. Now the other one goes on ticket costs and price. So I know that on I pay $8 for a regular ticket, so 8 times however many people bought it, plus $2 less than that for seniors times the number of seniors should equal my total amount of money, $3,580. And there's your 2 equations. And you kind of can see there's kind of a trend. The money goes with money. The numbers go with numbers. Go slow, and they all kind of look the same. Again, I think elimination would be pretty easy, if I can spell it this time. But I could also see substitution working pretty well because we have 2 variables without coefficients. Again, that would be up to you. Example 3. This is a very common type of question. A delivery van has a fixed charge for the first mile of travel and a charge per mile for each additional mile. If a 6-mile trip costs $6.90 and an 11-mile trip costs $11.40, what is the fixed cost for the first mile? So there's a cost involved no matter what we do. The second we call them, we have to pay X, the fixed cost. But on top of that, we have to pay for miles. We'll say Y is the number of miles. Now let's set up our equation. We've got 2 situations, a 6-mile trip and an 11-mile trip, but you need to remember something. In the 6-mile trip, the first mile is covered in the fixed cost. So I'm going to start with the cost that they're going to charge me, plus I know that I have to go 5 more miles. I just don't know how many miles, how much they cost. And that equals $6.90. And once you've set up the first one, the next one's easy. The fixed cost plus 10 times the number of miles, or 10 times the cost per mile, equals $11.40. So again, you could use elimination. I think that would be the best because the X's would cancel out pretty easy, but substitution could also be used. All right, look at a couple more. Number 4 says Jack has $3 in nickels and dimes. He has twice as many nickels as he does dimes. How many nickels and how many dimes does he have? This one is a little bit tougher. I'm going to go say that X is the number of nickels and that Y is the number of dimes. Now, I know in the first one, I think is the easiest, that he has a total of $3. I don't know how many he has, but I know that if I add them all up, he's got $3. Well, a nickel is 0.05 cents times however many nickels I have, plus 10 cents or 0.1 times the number of dimes, and I know that should equal $3. So not any big deal there. The next one's a little bit tougher, and this is where some people start having trouble. It says he had twice as many nickels as he did dimes. Now, I know that nickels is what he has more of, so I'm going to say X equals. And I know I have dimes over here. Well, it tells me he had twice as many nickels as he does dimes. So that means to make them equal, I'd have to double the amount of dimes. That is my second equation. X equals 2Y. And that's the one that most people are going to have trouble with. Since this one's already solved for X, I think substitution's a very easy way to solve it. And the last one like this. The difference of two numbers is 2. The sum of their squares is 10. Find the numbers. I'm going to say X is number 1 and Y is number 2. I don't know what they are, but it says the difference of the two numbers. So I'm going to say X minus Y equals 2. And the sum of their squares is 10. X squared plus Y squared equals 10. Elimination would be pretty tough here to make the squares on the top. It'd get a little mixed up. Substitution's the way to go here. So writing the equations not very bad. Be careful when you're writing them, though, because obviously if you have to solve them as well and you miswrite it, it's going to be incorrect. Let's talk about supply and demand for just a second before we look at this last question. The quantity of merchandise that a merchant has to sell is called the supply, so however much I have. The supply may be affected by storage space, speed of manufacture, or general availability of a product from the merchant supplier. The quantity of merchandise that the consumers wish to buy is called demand. So if all of us want to go out and buy a cherry Coke today, there would be more demand for that. Price also affects demand. A lower price tends to increase the demand, and a higher price tends to decrease the demand. When supply is greater than demand, the merchant suffers. The merchant has a stockpiled merchandise that they can't sell. When demand is greater than the supply, the merchant might also suffer. So what the merchant wants to do is get an equilibrium so they get the exact amount of product that they need to sell. So let's look at this question and see if we can figure it out. So we've got a marketer director for a chain of restaurants. They've decided to have a cartoon character doll made to sell at a premium price at participating locations. The company can choose from several different versions of the doll that sell at different prices. Went's problem is to decide which selling price will best suit the needs of console concessions consumers and managers. Went has data from previous similar promotions to help make the decision. So they've given us how much they sold the doll for in one column. They've given us the number that they got per week, and they've given us the number that were requested per store. So we're going to use these numbers to get some equations and see the exact price and how many they should get. So we're basically going to refer to this first column as our X values. And then over here we kind of have a Y1 and a Y2 situation going on. We'll use them specifically when asked. The first one says, use points given to find the equation for supply S, so there's supply, and price. So we're going to be using these two pieces. So it wants me to find an equation. Well, to do that, I have to find slope. And I'm just going to circle 2 points. I've got an X1, Y1, an X2, and a Y2. So X1, Y1, X2, Y2. And I'm just going to find slope. I'm going to take the Y's and subtract them, 130 minus 35, and divide that by the difference of the X's, $2 minus $1. When I do that, I get 95 over 1, and I have a slope of 95. So I know up here, I'm doing S equals, I know my slope is 95p. Now, I have to find my Y-intercept. So the way I'm going to do that is kind of what I have up there. I have an X and a Y I'm going to use. I'm going to circle it in red. I'll get rid of some of this in a minute. This is the X and Y I'm going to plug in to Y equals mx plus b. My Y is 35. I know my slope is 95, and I have an X that's 1, and I need to find my Y-intercept. Well, 35 equals 95 plus b. So I just subtract 95 from both sides, and I get b is negative 60. So my equation is 95p minus 60. We've been working on that for a while. Let me see if I can erase some of this. Now it switches gears on us, and I want to make sure you see this. This one says use the equation to find, or use the points to find the equation for the demand as a function of price. Now we're using the demand, the number requested per store, and the price for our equation. But we do the same thing. Here are my y's, here are my x's. I do the same thing. So I have 400 minus 530 over 2 minus 1 again. And for that one, I get negative 130. So I have a negative slope this time. Remember, we're talking about demand D this time, so negative 130 still times P. And we do the same thing we did last time. This time I'm going to use 530 and 1 as my points. Sorry, I'm writing all over the place here. So I have 530 for my Y equals my slope negative 130 times X my 1 plus B. That's 530 equals negative 130 plus B. So I add 130 to both sides, and I get B is 660. All right, go slow on those. Those are not bad ones to use. Now, the next one says use a graphing calculator to find the price in exact equilibrium. You can use a calculator. That would be no problem. I want you to not be confused here. You can say this is Y equals 95X minus 60, and this is Y equals negative 130X plus 660. Those are your two equations. You could put them into your calculator. You could find their intersection point. It'd be no problem. This one's pretty easy, though. If I set those equal to each other, then I've got what I want. So I'm going to say 95p minus 60. I want equilibrium, so when is that equal to negative 130x, or I'm sorry, we'll use p, plus 660. And now that's a pretty easy one to solve. I add the 130 to the other side. 95 plus 130 would be 225 p. I add the 60 to the other side, getting 720. And when I divide that, I get p is 3.2. So if you used your graphing calculator, you'd get the same intersection. So when is the price in exact equilibrium? When it's about $3.20. Now the next two, you got to be careful and make sure you use do the right things, plug in the right stuff. It says if Went sells the dolls for $250, how many disappointed customers will the store have each week? So how many customers will not get what they want? Well, to do that, I take my $250 and I plug it into both equations. So I know that S is equal to 95 times 2.5 minus 60. When I plug that into my calculator, I get 177.6. Then I plug it into the other equation, negative 130 times 2.5 plus 660. And when I do that, I get 335. Now you have to remember a couple of things. S is the amount that I have to sell. D is the demand. That's what people want. So there's 335 people wanting dolls. I only have 177 to sell. So I do 335 minus the amount I have. We'll do 177.6, but we can't sell half a doll. And if you do that and round, we get 157 people will not get the dolls that they want. The next one kind of asks the same thing. What if it sets the price at $380 per doll? How many unsold dolls remain at each store? So at $250, they couldn't get enough to sell. Here, apparently, we're not going to have enough, or we're going to have too many. So we do the same thing, though. S is equal to 95 times 3.8 minus 60. I got 301 for that one. So remember, that's how many we have to sell. The demand is going to equal negative 130 times 3.8 plus 660, and this is the demand. Only 166 people want one. If I subtract those numbers, I find out that I have 135 unsold dolls sitting in my inventory. So kind of complex, but actually very applicable to real life. So hopefully that's all right, but if you have any questions, let me know. If not, good luck.